okay, let's say you're putting the sample holder inside the microscope, you make a mistake and you forget to open the valve to pump out the airlock. What's likely to happen, these numbers will turn red and they'll stay red. It won't be for like 1 second. They'll stay in the red all the time. And you're going to hear from the electronics unit an alarm. The alarm sounds like this. Beep, 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 beep. That alarm is telling you that the pressure inside the column is too high to operate the ion pumps. The ion pumps don't turn off by themselves. The ion pumps are continuing to operate even though the pressure is too high. What can happen? If the pressure is too high and the ion pumps are running for too long of a time, that can damage the ion pumps. The ion pumps, the way they work, is that there's titanium plates that are all next to each other with a very small distance between them, and they have a very high voltage. If there's vacuum, it's good because there's no molecules between the titanium plates and there's very low current. If there's air inside, there's chance for a spark to go from one titanium plate to another titanium plate because there's something for the charge to go across, so the current becomes very high. That can damage the pumps, okay? So if you hear the alarm, the pumps are still running, the first thing that you do is turn off the ion pumps, okay? So if you hear the alarm, you turn off the ion pumps. The next thing you do is go get Jonas, okay? Jonas is going to be responsible for repairing the vacuum, okay? So everybody's job is you hear the alarm, you turn off the ion pumps, and you get Jonas. So what do we need to do? So first we need to understand how bad the vacuum is, the situation, and then we need to understand what happened, and then we'll go through the process of rebuilding the vacuum and conditioning the gun. And this is actually, I did it on the weekend. On Saturday and Sunday we did this procedure. And the procedure can take from a few hours to a few days, depending on how bad the vacuum is inside the column. Okay? So Jonas, you'll come and you'll look, you'll see the ion pump has been turned off, and you'll check to see, you'll ask what happened, what were they doing, were they loading the sample? That's usually the case, or were they doing something else, so that we can understand how the vacuum break occurred. You'll check to see if the sample holder is inside the column, or if it's outside, or if it's halfway, or somewhere in between. And then you'll send me an email. Okay? You'll let me know that this happened, and I'll put you in contact with our service people, and they will help you through this process of rebuilding the vacuum. In the manual, there's a procedure, and here there's also a user guide, care and troubleshooting, LVEM Ion Pump Alarm Procedure 1. So there's two, there's part 1 and part 2. Part 1 is restarting the ion pumps, okay? So the first thing that we're going to try to do with you is turning the ion pumps back on. So obviously the pressure inside the column is too high, so that's why we heard the alarm. We're going to verify if it's too high. Sometimes it could have been high just for a short time, for some strange condition. So the first thing that we're going to do, which takes 1 minute, is make sure that the sample holder is either inside the column or in the airlock. Okay? We want to make sure that the airlock valve is vertical so that there's vacuum on that side, so the pump station is on. Okay? Step 2 takes about 2 minutes. Switch off the ion pump module, so it should already probably be off. Okay? If it's not off, we make sure that it's off. And then we're going to turn it back on. So we'll turn it back on and we'll wait 1 minute. Okay? It might beep during that 1 minute, but if it stops during that 1 minute, we'll go to step 6. If it continues to beep, we continue to step 3. Okay? So if the alarm keeps ringing, switch off the ion pump button and start the turbo pump, if it's not already on. Okay? Start the microscope button, maybe it's already on, and the software, and you want to make sure that you get to the green light, okay, from the turbo pump, and then you wait 20 minutes more. So what we're doing is we're building very good vacuum in the airlock. Okay, so we get to the last green light, we have good vacuum, and then we wait 20 minutes to get even better vacuum. Because what we're going to do is use the turbo pump to improve the vacuum inside the microscope so that we can restart the ion pumps. Okay, so far is it okay? Yeah? We're going to help you through this type of thing. We have to just go through it so you understand the procedure, but we'll work on this with you by email and by phone or Skype. So don't worry, but it's important that you email us so that we can work with you on it, okay? So you wait 20 minutes.
I should not do it myself.
Yeah, best you should work with us. So you'll be here working and we'll send you emails and tell you what to do. Okay? Or by phone or by Skype or something else. But you should know what the basic procedure is. So the next thing we're going to do is open the back valve. Okay, so we've spoken about 2 valves already. We've spoken about the airlock valve, we've spoken about the inner valve, and there's one more valve called the back valve, and it's called the back valve because it's in the back. How do we open the back valve? So inside this box, we have 2 keys. One of them is big and one of them is small. We're going to use the big one. Okay. So this you need to know as to where to put the tool. Okay, so Jonas, you can come look. And can you see here there's a hole?
Yeah.
Okay. Inside that hole, the key goes inside, and this is a plate with a hole, and then somewhere around here, there's a nut. The nut looks like one of these. Okay? It looks like that, and the key goes inside the nut. So you put it straight inside. So it's important you put it straight, not like this. Can you see? Maybe you want to come to my side. Okay, so it's important, not like this, because you won't find the right place. You have to put it in very straight, and you'll feel it go inside. Okay, so now it's inside. If you put it in not straight, it doesn't do anything. Okay, so you have to put it in straight, and it goes inside. So now it's in the nut, and the nut, again, it looks like this. And you use the key to turn it until it stops. Okay, it's now closed, and we'll turn it the other way to open it. And it's like 2 or 3 full rotations, and then it stops and it's open. Okay? When you open that valve, this hose is now connected to here. So normally it's only connected to here, right, to the airlock. Now it's connected here to the sample chamber. So what you'll see happen is you would have had the last green, right, because we waited 20 minutes after the green. When you open it, the lights should change back to maybe red or yellow, because now it's pumping inside the column and there's pressure in the column. Okay? So when you contact us, that's what we're going to tell you to do, is to open the back valve. So that's the instruction here. Rotate 1 to 2 full turns until it stops, no force. At this point, you'll notice a change in the turbo pump gauge back to the first or second red. Okay? So the next step, this step takes time. This step could take maybe 1 hour. So now you need to wait until you get the last green again, so good back, and then wait 20 minutes after you get the last green light, so it can be even better. Okay? So that's step 5. Okay? Step 6, so this is where we're going to turn the ion pumps back on. Okay? So there's some procedure, some sequence that we need to follow. So we turn the IP button on for 30 seconds, and we check the values for ion pumps. Okay? Then we switch it off and we wait 3 minutes. Okay, so we turn it on 30 seconds, check the values, turn it off 3 minutes. Okay, then we do it again. We switch the ion pump back on for 30 seconds, we check the values, then we switch it off for 3 minutes. We do it again, 30 seconds on, 2 minutes off, until you see that these values are getting smaller. Okay, so when you first do it, you might see something like 1 times 10 minus 2, or 1 times 10 minus 3, I don't know, something like that, but not very good. But then you might see it goes from 1 times 10 minus 3 to 1 times 10 minus 4. It's getting better. And then you might see 1 times 10 minus 5. That's even better. So it's 10 times better every time. When you see these numbers, 1 times 10 minus 3 here, this is 1, sample chamber is 1, and IP2 is 5 times 10 minus 4, you can continue. And the next step is to leave the ion pumps on. So you've reached the minimum vacuum level to use the ion pumps. Okay? So we use that procedure, 30 seconds on, 3 minutes off. 30 seconds on, 3 minutes off. 30 seconds on, 3 minutes off, until you see vacuums that are better than this. Okay?
So that one is on and off, on and off.
Yeah, exactly.
But why do you do on and off?
Because you want to turn it on so that you can measure the vacuum. So you can only measure the vacuum when it's running, and you don't want it to be on if the pressure is still too high. Okay? And you want to give it a chance to rest, so 3 minutes in between. And when you see that it's reporting vacuum levels that are better than this, so anything smaller than that, then it's safe to leave it on. And then the next thing is going to be close the back valve. So same thing in reverse, you turn it the other way until it stops, and now the turbo pump is no longer connected to the sample chamber and the ion pumps are pumping. Okay? Once you do that, you can check these values, make sure that they're going down. They should be getting smaller and smaller. If they're not getting smaller and smaller, you could open the back valve again and you should contact us because it's something unusual. But if it's just from bad sample exchange, they should be going down, it should be pumping. At this point, you can turn off the pump station. You don't need it anymore. Yeah. You can close the LVEM software and you can turn off the microscope and let it pump overnight for the weekend. In this case, like when I did it, I left it like that on Saturday. Right? Saturday, all we did was pump. I left it by itself and the ion pumps were pumping. Okay? That's the end of the step, the first step. Okay?
Sorry. So when you turn off the pump station,
yeah.
and is it running, pumping, which pump?
Ion pumps. So the goal of this document, part 1, is to start the ion pumps. So that's the 30 seconds on, 2 seconds off, the back valve. Yeah. Once we get the pumps running, there's no alarms, and the vacuum levels are better than this, the ion pumps can run, and we need to let them run for some amount of time. And the next step is going to be conditioning the gun. That's what I did here on Sunday. So Friday, we had the problem, I restarted the ion pumps, and then Saturday I wasn't here, the microscope was pumping, the ion pumps were pumping, and then Sunday I came in and I conditioned the cathode, and that's the next step. Okay. So part 2, so that's the second document. Ion pump alarm troubleshooting part 2, gun degassing. So the goal, the objective, is during a long run with high voltage, the value of IP2, so this one, gun chamber IP, should generally descend below 7 times 10 minus 7, while the emission current will rise to a stable level, so emission current. Okay. So I'm not going to go through this with you now in detail, because this is a very variable procedure. Like this, you should be able to do it by yourself, but maybe there's a different way that you'll be able to do it, and it's situation dependent. So when you contact me or my service engineer and you tell him what happened and what the current values are, he might have a different procedure than this one. This procedure will work for all cases, but will take a long time. We could probably provide you with a procedure that takes less time, but we have to know exactly the values from the microscope. Okay? If you want, you can read this yourself, and if you have questions, I can answer them, but I don't think it is important for me to go through. I think it will just be a little bit confusing if I walk you through it right now. that okay? So this page is going to be about conditioning the cathode.
So you were saying that this one is we don't really need to follow the procedure exactly?
If you follow this procedure, this one will work in all cases, but will take a long, long time because it's like for the worst case scenario. Okay? If you email me, my service engineer will ask you some questions. He'll need some information from the microscope. He'll take that information and he'll change this to make it faster based on the current situation. Okay? And he'll give you step by step. He'll send you an email, okay, now change this value, do this for this amount of time, and then email me in 2 hours. And then you'll give him some information. He'll say, okay, looks good, change this, and email me in 2 hours. And then he'll give you instruction like that. That's the best way.
Is your service people responsive like immediately or?
It depends. Time zone is important. It makes it a little bit harder here, but it's a big difference. It's either Europe, so it's 6 hours, or East Coast, so it's 12 hours. But these steps take a long time. They take like 2 to 6 hours anyways. So if you send an email, we can respond to it, and you can do something, and then we can respond to it. And maybe we can give you like 24 hours worth of work to do, right? So it depends. Responsive, yes. It's not like you'll wait 1 week, but you might have to wait like a few hours until somebody is in the office. Okay. So what I was saying is I'm not going to read this to you step by step because the detail isn't important. What you need to know is how to restart the ion pumps, open the back valve, etc. And that the next step is conditioning the cathode. And conditioning the cathode, you need to work with us to make it go fast. Okay? So if you want, you can read it yourself after, and if you have questions, I can answer the questions. Okay?
The most common thing for degassing?
So vacuum breaks, they happen. Sometimes they're very small, and the degassing is like 1 hour. Sometimes they're very big, and the degassing is like 15
For the
hours.
small thing, for the degassing, is there a special button?
No, there's no button. We degas it just with turning on the high voltage. And what happens is, let's say it's a very bad vacuum break, the cathode, the electron source, gets a deposition of film, of contamination on it. And when you turn it on, it gets very hot, and that film burns off, and it goes into the vacuum, and it increases the pressure. So we need the ion pumps to remove that material. So there's a balance between turning the cathode on and letting the pressure not get too high. If the pressure gets too high, it can damage the cathode. So we have to run it maybe with some low setting, like low heat, so that the pressure doesn't go up so much, let the pump work, and then increase the heat. And then let the pump work, and then continue increasing the heat to normal value.
Talking about heat, you mean like voltage?
Heat, but so those are the details that I'm not going to tell you right now because maybe they're not necessary, and it's like it's maybe rare, and maybe you'll never need to do it, and it'll be too confusing, and it's inside the service panel, not in like the regular user panel. So it's kind of like a special case, but in principle, that's what's happening. If it's a very small vacuum break, we don't need to make any adjustments to the heating. We just need to turn on the high voltage and wait, and that's it. So that's like very fast. That's